Hi students, second problem in the exercise. In the Bohr atom model, the frequency of transitions is given by the expression nu equal to r into c, Rydberg constant into velocity of light, multiplied by 1 by n square minus 1 by m square. So this also can be written as 1 by n1 square minus 1 by n2 square, where this n1 is the reaching point, okay, that is lower energy state, and m is the starting point, that is the higher energy state, where n is less than m. Now consider the following transitions. So these three are the different transitions. An atom is returning in the first transition from n is equal to 3 to n is equal to 2 state. In the second transition, it returns from n is equal to 2 to n is equal to 1 state. In the third transition, it is directly returning from the higher energy state 3 to the lowest energy state 1. So these are the different possibilities. So the energy level diagram I have drawn. You can take the lowermost energy state n is equal to 1, and the middle one is n is equal to 2, and the highest is n is equal to 3. So when an atom is returning, what are all the possible states of returning from the higher energy state to the lower energy state? Directly the atom can jump from n is equal to 3 to n is equal to 1, during which it emits a radiation of frequency nu 3 to 1. Or intermediate, it can reach from 3 to 2 and then from 2 to 1. Okay, so here the transition n is equal to 3 to 2 emits radiation of frequency nu 3 to 2, and from 2 to 1 the radiation emitted as a frequency of what? Nu 2 to 1. Now we very well know that the law of conservation of energy is obeyed here. Therefore the energy radiated from 3 to 1 must be equal to the sum of energies 3 to 2 and 2 to 1. Since energy is directly proportional to the frequency, now we have to prove that this nu 3 to 1 must be equal to nu 3 to plus nu 2 1. We are going to prove this. Okay. So now the first case I will take n is equal to 1 and m, the higher energy state, is equal to 3. Okay. So this what we have to show that the frequency of transitions obey the sum rule, which is also called by the name Ritz combination principle. It is based on law of conservation of energy, that's all. Okay. Now we have to show that the frequency of transition nu 3 to 1 is equal to nu 3 to 2 plus nu 2 to 1. So first let us start with the case 1, where n is equal to 1 and m is equal to 3. So as per the given formula, the frequency of transition for this corresponding transition is 3 to 1. Okay. So the constants, Rydberg constant R into C into 1 by n square minus 1 by m square. So 1 by n square is what? 1 square. 1 by 1 square minus 1 by 3 square. Okay. So this is now equal to R into C into 1 minus 1 by 9. Okay. So this is equal to R into C into 9 minus 1 is 8. So this is 8 by 9. So this is equation 1. Okay, so I have found the frequency of radiation emitted during the transition from n is equal to 3 to n is equal to 1. Similarly, these two transitions we will find out. So case 2. Now I will take n is equal to 2 and m is equal to 3. So n is equal to 2 and m is equal to 3. So here the frequency of transition from 3 to 2, so nu 3 to 2, this is equal to R into C into 1 by n square. So 1 by 2 square. So this is equal to 1 by 2 square minus 1 by m square is what? 3 square. So this is equal to r into c into 1 by 4 minus 1 by 9. So taking LCM r into c. So this is a 9 minus 4 by 36. So this is 9 minus 4 divided by 9 4s are 36. So this is now equal to r into c into 5 by 36. So this is our equation number 2. Similarly, what is the third transition required is 2 to 1. So the third one. So here n is equal to 1 and m is equal to 2, let us take. Okay. So here now nu 2 to 1. So nu 2 to 1 is equal to r into c. So 2 to 1, 1 by n square. So this is a 1 by 1 square minus 1 by 2 square. So this is equal to r into c into 1 minus 1 by 4. 1 minus 1 by 4 is what? 3 by 4. Okay. So this is now equal to r into c into 3 by 4. And this is our equation 3. We have to show, okay, that nu 3 to 1 is equal to nu 3 to 2 plus nu 2 to 1. Okay. So now let us take, I will add these two, 2 and 3. So I will find out the sum of this 3 to 2. So this is nu 3 to 2 plus nu 2 to 1. I will find out. So what is this now equal to? Now RC is the common factor, is it not? RC is the common factor. So I can write like this, R into C as a common factor, and 5 by 36 plus 3 by 4. So this is 5 by 36 plus 3 by 4. So this is now equal to R into C into common factor. No, this is LCM. LCM is 36. So I will take LCM as 36. So this is 5 plus this is 9 4s are 36. So 9 3s are 27. So that this is now equal to R into C into 27 plus 5 is what? 32. 32 divided by 36. Now these two numbers both are divisible by 4. Is it not? So 8 4s are 32, 9 4s are 36. So this is also equal to R into C into 8 4s are 32 and 9 4s are 36. So that 4 can be cancelled, and this is equal to what? RC into 8 by 9. Okay. So what is this transition? Sum of the frequencies 3 to 1 plus 2 to 1. And already we have proved that nu 3 to 1 is equal to what? RC into 8 by 9. So this is now equal to frequency of transition 3 to 1. Therefore nu 3 to 1 is equal to nu 3 to 2 plus nu 2 to 1. This formula only is called as Ritz combination formula. So you can also write this in terms of energy. The energy of transition E3 to 1 also is equal to what? E3 to 2 plus E2 to 1. It is simply law of conservation of energy. I hope you must have understood well. Fine.